TDP Data Systems is a Swiss Army knife for precision decision making. TDP de-risks and compresses decision making by 80% or more, with more options. TDP can pivot upon a moment's notice and can vector soft to the resources needed, to include capability assessments. Resources include startups, companies, technologies, people for procurement across SOFT's 13 missions, including contested logistics and force projection. Having ingested a growing number of databases and datasets, now at 1,000, TDP does this by restructuring various data types and then merging them into unique combinations to provide focused resource sets to be assessed for the problem at hand. TDP's combination of advanced computing and human intelligence can make sense of what is viable from the data, including scoring startups or any resource, for the ability to execute and survive. For this presentation, TDP will provide 5 examples of how it can be applied: for procurement, for contested logistics, for casualty and medical evacuation, and for comms. To compress the time for procurement and to leapfrog the sources sought in RFI processes, TDP has ingested the data from the federal government and has built a rolling 24-month model to identify and evaluate cohorts of potential prime contractors and subcontractors for any contract or grant solicitation for contracting officers. TDP also uses this to allow potential primes and subcontractors to evaluate solicitations for their attractiveness and to grow and reinvigorate America's defense industrial base. TDP can assess both the demand and supply side for any set of keywords run through its dynamic model. For this, TDP's advanced computing assesses vast amounts of data and does so objectively, which humans cannot do. From this process, TDP automatically generates scorecards that humans can then apply their expertise in subjective evaluation and deal with new and novel situations which computers cannot do. With a push of a button, TDP algorithmically generates a solicitation scorecard assessing how attractive the solicitation is to be pursued by contractors based on analysis of the type of solicitation, such as recompete, open, or a new solicitation, barriers to the solicitation being awarded based on geographies and/or legislators involved. Based on the solicitation scorecard, TDP algorithmically generates and scores a cohort of potential primes that could compete for the solicitation. For each prime in the cohort list, TDP generates a scorecard with algorithmically produced scores. These include a contractor or subcontractor score that evaluates the experience and impact of the entity in performing government contracts and grants, and an analysis of the number and value of contracts the entity has been awarded and performed. Also included is an opportunity fit score on how well the potential awardee aligns with the parameters of the opportunity based on the text analysis and capabilities of the company and opportunity descriptions, which is an analysis on how well the size, scope, and scale of the opportunity align with the potential awardee. Since at the frontier of science, emerging technology, and startups, there tends to only be partial solutions. TDP algorithmically assesses, scores, ranks, and combines various resources as components to fit in a holistic solution, or TDP ecosystem maps. TDP can generate these maps in an hour or less. TDP is providing examples for contested logistics, casualty and medical evacuation, and for comms. As demonstration of how TDP produces its ecosystem maps, TDP generated one focusing on the challenges of contested logistics. This is for real-time rapid manufacturing of customizable, attritionable drones. The first step to generate the ecosystem map is to expand through machine learning the various sets of keywords that describe the components of a holistic solution. The next step is to perform dozens of crosses by overlapping various technologies and providers to find specific solutions. TDP developed this process because you can't just type bundle fusion and computer vision into PitchBook or Crunchbase and generate any meaningful results. The third step is to generate cohorts of potential solution providers for each component of the ecosystem map. This includes algorithmically evaluating, scoring, and ranking members for each cohort. This process provides optionality and choice regarding whom to work with in generating a holistic solution. The final step of the ecosystem mapping process is to generate a graphical representation of the proposed solution. For this particular solution, TDP is proposing a transportable pod for manufacturing attritionable drones on demand. It includes technologies around portable pods from companies like Ecosphere, which incorporates solar capture in its products. The solution also incorporates energy capture through sand batteries and energy storage through sand batteries and nanocrystal battery packs. Inside the pod will house equipment for both polymeric and metal additive manufacturing equipment, as well as additional materials to supply the manufacturing processes and additional components to complete the manufacturing of the drones. The last component of the ecosystem map incorporates metamaterials to the outside of the pod. This will be used to mask heat signatures created during the manufacturing processes within the pod, as well as to mitigate any additional signatures that may give away the pod's location to the enemy. This approach is dynamic and customizable to the operations at hand. While the first example was for a tropical setting in the Pacific, the same approach can be used for a different environment such as the Arctic. Here you can see the energy supply and storage of sand has been replaced with small silicone sensor generators that can harvest electricity directly from the snow, which is technology coming from UCLA. This makes the solution dynamic in nature to support the needs of any operational vector. As another ecosystem map example, TDP generated one focusing on supporting casualty and medical evacuations. This is for dynamic evacuations incorporating suspended animation and automation. For this example, we skipped the first two steps to produce ecosystem maps and are just showing the third step. This step is to generate cohorts of potential solution providers for each component of the ecosystem map. This includes algorithmically evaluating, scoring, and ranking members for each cohort. This process provides optionality and choice regarding whom to work with in generating the holistic solution. Here's the graphical representation of the proposed solution. The first step in this proposed solution is to stabilize the wounded or incapacitated individual. This includes any emergency medical supply deliveries to the front via drones. This could be the form of additional blood or any other supplies that medical personnel on the ground may need. To properly evaluate the situation, various wearables and sensors will be used to gather information on the individuals impacted. Examples here include EEG sensors that can be integrated into helmets and headsets, and sweat metabolite wearables to help quantify the trauma that was experienced. Depending on the severity of the trauma, additional technology can be incorporated. This includes hibernation-like suspended animation, HLSA, through the accumulation of uric acid. This research is coming out of the government of Singapore through the Agency for Science, Technology, and Research. This approach has been verified in various animal models, which induces a controllable hibernation-like state. This state can reduce inflammation and heart rate for the injured individual. This state can stabilize the individual until an autonomous robot can come and collect them and bring them back to a line of safety where helicopters can then transport them to get the medical care that they need. Once in safety, the forced hibernation can be reversed with no damage done to the organs. The last component to the map is a drone defense system behind lines to create safety corridors for the robots transporting wounded individuals. This is a third ecosystem map example. TDP generated one focusing on comms challenges. This is for secure, durable, and covert comms. Again, for this example, we skipped the first two steps to produce ecosystem maps and are just showing the third step. This step is to generate cohorts of potential solution providers for each component of the ecosystem map, including algorithmically evaluating, scoring, and ranking members for each cohort. Again, this process provides optionality and choice regarding whom to work with in generating a holistic solution. This specific solution leverages more theoretical solutions that are in the research stage. This includes blockchain-based transaction communication systems, which ensures robotic teams achieve their goal even when robots are hacked. It also includes a UAV-assisted blockchain-based secure device-to-device communication in the Internet of Military Things. This is to ensure secure communications, operator to operator, operator to equipment, equipment to operator, and equipment to equipment. The system also includes technology for the development of anti-jamming, low observable waveforms for microcommunication satellites. This is to ensure reliable networks anywhere in the world, regardless of the circumstances on the ground. The ecosystem also includes technology from the University of Mississippi. This is network cloaking through various metasurface approaches. This enables covert communications across the network, as well as protecting on-the-ground locations of operators interacting with the network. Also included is SALT, a startup focused on peer-to-peer messaging with multi-level encryption for both voice and text messaging. This is primarily for individual to individual, team to team, or individual or team to base, and vice versa. TDP's approach to domain awareness goes beyond a current snapshot, but rather awareness of an evolving domain with its various resources, feedback loops, and rates of change. TDP provides domain awareness across unlimited use cases. This includes TDP combining both predictive analytics and real-time solution generation. TDP does this by producing dynamic models that draw inputs from a wide variety of data types, ranging from socioeconomic and social sentiment to technological and financial, to environmental, geospatial, and geopolitical. TDP creates these models using its 150 algorithms from its growing proprietary library as building blocks to be combined to transform the various data types into real-time, actionable information. To provide domain awareness for NIH's Pathway to Excellence and Innovation program with HBCUs, TDP ingested and developed frameworks and dynamic models to heat map nutritional deserts and assess HBCUs' capacities to help address those deserts. For domain awareness at the global, regional, and local levels, TDP can heat map and track the emergence of any capability, resource, activity, or phenomenon. In this case, TDP is tracking AI research and patents using a granular bottom-up approach. TDP can predict social sentiment, phase transitions, and emergent properties at the community, census tract, city block, and individual levels. Starting in 2022, TDP began entering challenges from the federal government to test how generalizable and extensible its system was to produce solutions for any type of pain point. Using its approach, TDP was a winner of a rapid staffing challenge from the DoD. For the challenge, TDP included developing algorithms to assess a candidate's probability to pass a TS-SCI clearance. Along with Booz Allen Hamilton, TDP, using its modular approach, was a winner of a model-based systems engineering challenge from the DoD. TDP's approach was to transfer data up or down classification levels while maintaining, controlling, and synchronizing a specific model's core configurations. TDP opened its platform as a service to students who used it to win a USAID challenge to address ocean plastics emanating from the Philippines. The Philippines generates 70% of the world's ocean plastics, which may also interfere with naval operations. TDP also generated for USAID an ecosystem map to support the protection of biodiversity in the Peruvian Amazon, which in turn can be a bulwark against transnational corruption and terrorism. When the EU stated that one of its missions is to protect global biodiversity, TDP provided the EU this TDP ecosystem map to demonstrate how the support of indigenous peoples and their land rights can protect biodiversity. As America's soft power through Hollywood content and fast food wanes, the opportunity is to offset this decline by making available and accessible around-the-world data that has been transformed into actionable information. This will be in contrast to the restriction of information by authoritarian regimes. TDP's approach has proven itself to a market-tested, trustworthy AI solution that is generalizable and extensible, including for the art of the possible, point solution generation, revitalization of the industrial bases and supply chain, and for data security. TDP is a Swiss Army knife for precision decision-making across U.S. SOCOM's 13 missions and across the missions of the federal governments, departments, agencies, sub-agencies, and bureaus.